Okay, so this is our third day of working on section 5.2. The reason we spend so much time on it is because it's so important to future math success. You have to know how to simplify values, and you've got to get common denominators, and you have to make sure that you write rational exponents in the simplest radical form. Those are all important skills to have. So the directions say write each expression in simplest radical form when needed. So if we just have x squared, we don't need radicals because it's just x squared. But if I have x to the 1/2, how do I need to write it? Radical x, right. Rather than using rational exponents. Use only positive exponents and make sure to rationalize the denominator. Use absolute value when necessary for variables. Can anyone explain how we know when absolute value is necessary? Go ahead, Noah. Okay, so we start with an even exponent and we get an odd result. That's one thing that's true. There's another part to it, though. Tim? It has to be a variable, right? Something else, too. It's not really when we start with an even exponent. It's when we start with an even root. Yeah, that's what I was looking for there. All right, so starting with number 1, this one shouldn't be so bad for you. We're trying to do the 6th root of 8. Keegan, what would you do first?
You do the 6th root of 2 cubed.
Good.
And I think 5 to the 1/2 power, which is rational.
Good. That's all we have to do with that. Whenever we see one of these roots like this, we want to check to make sure that we can't write it in a different way. So, 6th root of 8, if that was my final answer, that's not the best answer because it's not simplified. It can go down even further to radical 2. If I were to check this on the calculator, maybe I did this work and I'm like, I'm not sure that's correct. I could see if they're equivalent. I don't know if I've shown you guys this, but if you go under math, we have all these roots here. If I go down to number 5, that's the xth root. It asks me, what root do you want? I want the 6th root of 8. And here's that answer right there. Well, now I'm going to see, is that the same thing as radical 2? And it is. They're exactly the same. One looks much simpler. Radical 2. Okay, let's look at number 2. When I'm looking at this, first thing I want to check, is this multiplication or is this addition and subtraction? What is it, everybody? Multiplication. So I have to make sure that everything gets raised to the -2 power. Again, there are multiple ways of doing this problem. It might be easiest just to go ahead and raise everything to the -2 power. So I have 5 to the first to the -2. There's a 1 there. You have to make sure that you multiply 1 times -2. We get 5 to the -2. What's x going to get raised to? 2. How about y? Good. Okay, now I want you guys to take a second and simplify it on your own. Danielle, what did you get?
X squared divided by 25 y equals.
Good job. You're correct. Anybody need help with it?
Is there any way to know, when you go over?
Well, I would check and see if I have an x here, I want to make sure that there's no x in the denominator. Same thing with the y. If there had been another y in the numerator, then I would know I'm not completely simplified. But there's nothing else I can do with this. So we're done. Okay, look at the difference between number 2 and number 3. Number 2 was all multiplication. It's a pretty easy problem. Number 3 is not multiplication, it's addition. This problem is the same thing as a plus b squared. What would you have to do on a problem like this? FOIL it out. That's the same thing you have to do here, is FOIL it out. You must follow the rules. Here's what I see people do. They square that, and they think they're done. Wrong. You have to make sure that you multiply it out completely. If you feel comfortable with it, you can try it on your own. Otherwise, let's try it together. We do the first times the first. That's going to give us 25x. When we're multiplying and the bases are alike, we add the exponents. I go to this one. That's going to be 5x to the negative 1, y squared. I go to the inners. That's going to be 5x to the negative 1, y squared. I go to the last, and that's y to the 4th. When I'm multiplying, the base stays the same, add the exponents. Now I want to look at my terms. Do you guys see something we could do here with these middle two terms? Add them, can't we? Because they're alike. These two are like terms. So we have 10 of those. Okay, looking back at how we know when we're simplified. Says only positive exponents. We have a negative exponent there and a negative exponent there that we're not allowed to have. Do you know how this would be written then? Yep. This would be 25 over x squared plus 10. The 10 stays where it is. The y squared stays where it is. But this x has to go to the denominator. Now, on a problem like this, if this is multiple choice on your quiz or test and on the ACTs or whatever, they would get a common denominator for these terms. Whenever you can get a common denominator, you should get a common denominator. Olivia, can you think of what the common denominator would be? Not sure? Anybody think they know? Noah? X squared. It's just like if I had had a 4, which is 2 times 2, and a 2. Okay, so like we have an easier problem. Let's think of an easier one. If I just had to add 1/4 plus 1/2, wouldn't your common denominator be 4 and 2? Because this is 2 times 2. So I would multiply this by 2 over 2. Okay, so this is the same kind of thing. It's just that this is x times x. So we have to multiply this by x and this by x. Well, what am I going to have to multiply this one by? Everybody? X squared over x squared. So then we're going to have 25 over x squared plus 10xy squared over x squared plus x squared y to the 4th over x squared. So now we have a common denominator. So now we can write this whole thing just over x squared.
So all you're doing for this, like 10y squared over x is just multiplying by x.
X over x. I have to multiply by 1. I'm not allowed to change the value. If I multiply by x divided by x, I'm really multiplying by 1, so I'm not changing the value of something when I do that. So if I multiply the bottom by x, I must multiply the top by x too. Any other questions on that one? All right, let's go down to number 4. Okay, we got to think what we want to do first. There's a lot of different ways to approach this. Think about it, what you want to do first. There's no right or wrong answer as long as you don't break a rule of algebra. Clara, what would you do first? Okay, she's saying she wants to flip it. If I flip it, that's going to get rid of the negative on the 3. So we're just going to flip the entire thing. I'm not going to change anything. I'm just flipping it over. Okay, that's legal to do. Don't try to do too much in one step. What do you want to do now? Rachel, what do you think? What would you do now?
Add 1/4 1.
Okay, and why would you do that?
Because you have to bring the negative.
Okay, so here's what she's really saying she's going to do. She's going to make this a 1 on top, and she's going to bring this 5 to the 1/4 on the bottom. So she's doing this because she said she's going to add 1/4 and 1/2. What is 1/4 and 1/2, guys? 3/4. So now I have 1 over 5 to the 3/4 cubed. Okay? What do you want to do now? Alexis, what would you do? Let's get rid of the 3. So what's this 3 mean we're going to do to both of these? We're going to cube them, right? So what's 1 cubed, Alexis? Just 1. And do you remember the rule when I have a power to a power, what I do with the exponents? Multiply them. So this is going to be 5 to the 9/4. All right, guys. Now here's where we have a bit of a problem because that's not our final answer. This is what we really have at this point. We've got 1 over the 4th root of 5 to the 9th. Okay, that's what we have right now. So that's going to be, I need to know, how does this simplify? The 4th root of 5 to the 9th. Well, here's what it means. I've got the 4th root of 5 to the 4th times 5 to the 4th times 5. Everybody see why it would be the same thing as that? Because it's 5 to the 9th, and I'm making these to the 4th, because what's the 4th root of 5 to the 4th? Just 5. So this 5 will be able to come out, this 5 will be able to come out, but I'll still have this 5 down here. Remember how we have to have that denominator rationalized? So how many more 5s do I really need to be able to take this one out too and not have a radical under the denominator? 3 more, don't I? So I'm going to be multiplying by the 4th root of 5 cubed. That's kind of difficult to understand, but the reason why we do that is because I need to have 5 to the 4th on this factor. So what I've got now is the 4th root of, and I might as well go ahead and do this. What is 5 cubed? 125. On the bottom now, I've got the 4th root of, I've got 5 to the 4th, 5 to the 4th, and now I have another 5 times 5 cubed, another 5 to the 4th. So what's going to come out is a 5, and a 5. So what are we going to have in the denominator then? 125. That's one of the more difficult problems. Let me show you another way we could have done this and gotten through it a little quicker, but I just want to make sure everybody understood it, so I kind of did it the long way. If I have 1 over 5 to the 9/4, these must be evenly divisible for us to not have a radical in the denominator. What is the next number after 9 that's divisible by 4? 12. So how many more do I need? 3. So right here, I could have multiplied by 5 to the 3/4. I could have left it in this kind of form. So do you see now how I'd have 5 to the 3/4 over 5 to the 12/4? Well, what's 5 to the 12/4 the same as? 5 to the 3rd, which is 125, and then I've got the 4th root of 5 cubed. See how I could have done it that way too? You can choose your way. You just have to be good with the exponents and not break any rules. Okay, let's go here to number 5. Let me have you guys kind of start it. Well, actually, no, I'm going to go with you on this one because it can get bad really fast if you choose the wrong thing to do. What is very tempting to do first? Square it, yes. Do you want to deal with 27 squared? Probably not. So rather than squaring it first, I don't have to square it first. See, I can think of it like this. That's the same thing. Just wait to square it later. Why is it better to take the cube root first rather than squaring it first? Smaller numbers, yes. I don't want to do 27 squared when I can do the cube root of 27 is 3. What's this going to turn into? If I have a to the -6 in the cube root, Good. And if I have b to the 3/4 and I have the cube root, here, let me write it like this. What's that going to be? 3/12, which is? So this is going to be b to the 1/4. But what do we still have to do with it? Square it. Now square it. Okay, so now go ahead and finish it. I want you to finish it on your own. Brooklyn, what did you get?
I got non-radical cube root of 4.
Anybody agree with her? She's correct. So that is good work. What about absolute value? Do we need it around the a to the 4th? Because it's always going to be what? Positive, so we don't need it. All right, number 6. Before I just start multiplying by the conjugate, that's very tempting to do. Is there another way I could write the 4 through to 25 to make it easier? Radical 5, good. So I'm going to write it like this. Now go ahead and multiply by the conjugate. And if here, what do you think the answer should be then?
-6 plus 2 radical.
Good. We have to divide this by -1 and this term by -1. They're both getting divided by -1. That's our answer.
Can you explain this problem?
Yep, I'm multiplying by the conjugate, so I change that middle sign. Whatever I multiply the bottom by, I have to multiply the top by. Do you understand that part? So now I'm distributing and multiplying, just distributing this all out. The outers and inners become -2 radical 5 plus 2 radical 5, so those are 0. So then the top just stays the same, and the denominator is 4 minus 5, which is -1. Divide each one by -1. All right, on the back, guys. Okay, number 7, take a look at it. It's multiplication. Multiplication here. Morgan, how can I rewrite this first value in rational exponent form?
You write 1 over 3 a to the 4th.
Do you want to keep it under the radical then?
No.
Okay. If you don't want to keep it under the radical, though, you got to think, what's the root?
1.
Nope. If we don't see a root, guys, what is the root? 2. Remember that because it's a square root? Okay, so this is going to be actually then a to the -4 over 2, right? Let's not try to get rid of the negative exponent quite yet. I think it's easier if you wait a little bit. Okay, so how do we write the next one then, Morgan? How do I write that one?
A to the 3/4.
Good. And then the last one?
A to the 1/4.
Okay, good. Now I think it's a good idea to go ahead and take that down to the denominator. And while I'm at it, what should I do with these two if I'm multiplying, guys? What do we do with the exponents? Add them. So now we're going to have just a to the first, and then this is a to the -2. And so what's it going to turn into if I take it to the bottom? A squared. Something else we have to think about on this one, though. Sai, what do you think the final answer is?
Would it be a over radical a?
No, you can't take the square root of top and bottom. That's not allowed. See, look, if you take the square root of something, like let's say our answer is 1/4, and you decide, hey, that's my answer, but I'm going to take the square root. Is that equivalent? So we can't do that. All right, so what? Do something different. Go ahead, Sai.
Make it 1/x.
You could. But what if I said that's not completely right? Does anybody know why that's not completely right, Tim? Bars, absolute value? You are correct. Jacob, can you explain why we need the absolute value? Right, it has to be a positive A value. And because it's an odd exponent, it could be negative, but it needs to be positive. Because I can't take the 4th root of a negative number. That's imaginary. And we're only working in the reals. There we go. Okay, guys, building, getting a little tougher here. Let's think of how we can rewrite this. Guys, the biggest clue on simplifying these is to get like bases. Okay, get like bases when you can. And it's going to make everything easier. Ryan, how would I write this one?
7 to 1 half.
Good. All right, what about this one? I want a like base with this one if possible. Go ahead, Anish.
7 to 1/5.
Good. You kind of skipped a step. Do you guys see how I got that? Because 49 is 7 squared, so we had 7 squared squared. 7 squared squared, 7 to the 4th, 5th root. Okay, divided by, Anish, go ahead and keep going on this one.
7 to 2/5.
Good. All right, so now let's look. We're multiplying. Multiplying here. What do we do? Gitanshu, if I'm multiplying and my bases are like, what do I do with the exponents? Add them. Do you know what you get if you add those two? Nine tenths. So she's got 7 to the 9/10 divided by 7 to the 2/5. What do we do if we're dividing and our bases are alike? Subtract. Okay, Jessica, what do I get if I subtract those?
7 to the 1/2.
Good. Okay, and then what's another name for 7 to the 1/2, everybody? Radical 7. So all of that mess up there just is radical 7. Okay, just trying to simplify. Look at this one. Looks so fun. I love these. All right, guys, a clue. Work from the inside out. Makes things easier if you start from the inside out. I also like to look at these numbers and think about how can I get that common base? That common base. Meaning I want it written as an exponent and I want the base to be the same. You might be thinking of this as 4 squared, but can I write this as 4 to some power? No, so what's the base that I could get that would be the same? 2. Okay, so let's work from the inside out. What is this then? 2 to the what? 4th. But what root are we taking? 3rd root. What other root are we taking? So to the 1/4. Then what are we doing? No. Cubing. Sorry. We're cubing first. Now we're dividing. All right. Redeem yourself, Tim. How are we going to do this? 8. What is it?
It'd be 2 to the 3rd.
Okay, what root?
The 2nd root.
Yes, good. And what other root?
The 3rd root.
Okay, and how do I write it?
1/3.
There you go. Okay, now it's not so bad. Look at this. We have just a power to a power to a power, power to a power. See if you can finish.
So you're multiplying all these roots.
You tell me. Is that what you should do? Evan, what'd you get? Did you get it finished? Not quite finished? Okay.
So one
Halima, what do you think?
Radical 2.
Radical 2, do we agree?
Yeah.
I do. Radical 2 is correct. Okay? When we get it down to this point where we have 2 to the first over 2 to the 1/2, subtract those exponents. That's 2 to the 1/2. That's radical 2. Questions on that? All right, last one, guys. Toughest one here. All right. Take a deep breath and let's try it. 8, 2, 2, 4. What should our base be? 2. All right, good start. What do we do now? What ideas do you have on what we can do? Brooklyn, how can I rewrite radical 8? You're not? Go ahead. 2 to the what? It's not 2 to the 1/3. It's because what's happening to the 2 to get you the 8? There you go. 2 to the 3/2 there. All right, let's work with the bottom now. What do we do when we have a power to a power? What's the rule? Power to power, what do we do with those? Multiply. So we have 2, let's multiply those. 2 plus 2 radical 3. All right, Anish, what are you thinking?
Would you, like, do it to the power of the conjugate of it? So, like, multiply the power thing by 2 minus 2 radical?
No, because this isn't just a value in the denominator, it's just an exponent. So we can't do any conjugate work when we have it as an exponent. All right, guys, let's think about this for a minute. We are dividing. So if I gave you 1/3 divided by 1/6, what would you do? You would do 1/3 times 6, right? Okay? This is the same thing. It's something kind of more difficult, a lot more difficult. But what am I going to do? I'm going to change this to multiplication, right? Okay, so this is now going to go to the top, and this is going to go to the bottom. Let's do the easy part first. Radical 2. How do I write it in the denominator? 2 to the what? 1/2. No, 2 to the 1/2. Right? Radical 2 is 2 to the 1/2. Okay, this has to go to the top now. We need a base of 2, though, so 4 is going to be what? 2 squared, but then we still have this radical 3 minus 1. Now, I want you to think about the fact that if we are dividing or multiplying or anything, like look at this. I could give you a problem. 6 over 8 times 2 over 3. Okay? I may not decide to simplify by going up and down. Couldn't I go this way too? I can say 2 and 8 would be 1 and 4. 6 divided by 3 would be 2 and 1. 2 and 4. This answer is 1/2. Do you see what I'm doing there? I can go in any direction with my dividing. I just want you to keep that in mind on this problem. Now, if I have this power to this, what am I going to do with that? I got to distribute it, don't I? Let's go ahead and do that. I'm just going to put this all on the top too. And this is all on the bottom. Now, think about what I said. These can all be canceled out however I want to do it. I could do this part and this part, but I could also do this way and this way. Doesn't matter. what do I do if I'm dividing and my bases are alike? What do I do with these exponents? Subtract them. So what's 3/2 minus 1/2? So I would get 2 to the first when I work with those two. Now I'm going to work with these two and divide them. So I have 2 to this divided by 2 to this, so I have to do subtraction with these. So what is 2 radical 3 minus 2 radical 3? 0. What is 2 to the negative 2 minus 2? 2 to the negative 4. That's what I get when I do this part. So now, what do I do if I'm multiplying and the bases are alike? What do we do? Add the exponents, and what's the answer to all of that? Just 1/8. 1/8 for all of that. Okay? That'd be like number 60 on the ACT. When you're running out of time, you have like 20 seconds left, you come across this problem and you're like, oh gosh. But that all simplifies down to 1/8. Yeah?
I got the 2 to the first, but what did you do to get to
Negative 4? Okay, so I had to do 2 radical 3 minus 2 radical 3. That's 0. Then I had to do negative 2 minus 2. That's negative 4. And so now my bases are alike, and I add the exponents, and that's 1/2 to the third, which is 1/8. Okay? All right, guys.